In this video, we'll look at the problems in week 6 practice that cover topics, those minor topics that are not covered in previous practices. All right, so let's look at the problem number 1. Mark has 20 dimes and quarters in together. If the total value is $3.20, how many quarters does he have? Okay, so this is a simple question, and there are different ways to solve this. What we are going to use is we are going to use algebra, which is the most convenient one. Okay, let's practice using algebra. All right, for algebra, that means we are going to use variables and set up equations. So let x be the number of quarters. You see, this is basically, it's a chicken rabbit problem, right? Because quarter and dimes, they have different values. And then the number of dimes will be 20 minus x, but in total is 20. Okay, and then from here, we're going to set up the equation. Then we get a total value equals quarter is 25 cents, and then dimes, each dime is 10 cents, right? Okay, so then this is the total value. It's 320 cents. All right, so then, okay, so from here, let's simplify the equation. So we got 200 minus 10x is 320, and then from here we combine like terms. 25x minus 10x, this gives us 15x, and then we can move this 20 to the other side. So basically, we just minus 200, right? It's 200 on both sides. Okay, so then we get this one equals 120. All right, so then x is 120 divided by 15, and you get number is 8. Problem number 2. Julia and her daughter Megan and Zoe have the same birthday. Today, Julia is 32. Her daughter Megan is 4, and Zoe is 1. How old will Julie be when her age is the sum of the ages of Megan and Zoe? Again, let's use algebra, which is very robust. Okay, so now let's see the ages. Right? So Julia is this year is 32, and Megan is 4, and Zoe is 1, right? Okay, so let's say after x years. Okay, so x is the variable. We're going to solve this. So after x years, the age, right? Ages. Julia will be 32 and plus x, right? And then Megan will be 4 plus x, and 0 will be 1 plus x. Now we can have equation, because here says this the age of Julia equals the sum of the age of Megan and Zoe. Okay, so then we get this one equals this plus this, right? Okay, this is the equation. All right, what do we have? Let's simplify the equation. Plus x equals 5 plus, you have 1x here, you have another x here. So you just get 2 copies of x here, right? Okay, so then you have x, 2x. What you do is you minus x on both sides. In other words, you move x to the other side. And then also you have 5, right? 5, okay, just minus 5, you cancel. Okay, what do you have? Then we just get it's 27 equals x, right? X. Okay, so this tells us, okay, after x years, so after x years, the age of Julia equals the Megan plus Zoe. Okay, so then the answer will be, because here looking for the age, so the answer will be 27 and plus 32, which is 59. Okay, question number 3. A company has bought a number of flower pots of the same price from a factory. Before those flower pots can be sold for profit, 20 of them are broken by mistake. For the remaining flower pots, if each one is sold for $5 more, okay, so here's $5 more than the original price, the company will lose 150. So when I say lose, means compared to the cost it spent on binding all those flower pots, it lost 150. So if each one is sold for $10 more, again, it's more than the original price, the company can earn 250. That means that the revenue will be 250 more than the cost spent on buying those flower pots. Okay, the question is, how many flower pots have the company bought? Again, what we're going to do is let's use variable, right? Let's say, okay, it's X. So X is the number of flower pots bought, right? But you see the problem says 20 of them were broken before they could have sold to get a profit. Okay. Then X minus 20 will be the number of flower pots sold, right? So that is able to be sold. Okay, and then if it's so, then we get two equations. Equation 1, equation 2. Equation 1 is we said if it's $5 more than original price, so it's okay. So if this X minus 20 sold for okay, so the original price, regardless what it is, right? Original price plus this $5. If that's the case, right? It lost 150. So that means it will be the total cost, right? To bought minus this 150. So it's less than 150 of the total cost. So that's okay. That's why you lost money. And but if you sold, okay, if you sold $10 more, so original price plus $10 more, then it will be the total cost and add 250, right? So that's your profit, right? That's your profit. Okay, now from here, you see, we could quickly just get equation, because if you take the difference, you say, okay, if I have this one minus, if this minus this, what you get? You get X minus 20, right? You get X minus 20, and then this is original price, so this cancel, so you get a 10 minus 5. This equal total cost cancel together, so it just be, we'll get it 400. Okay, so from here, right? We just get X minus 20 times 5 is 400. Okay, so X minus 20 equals minus 20 equals 80. Okay, so then we get X equals 100. Okay, problem number 4. This is a puzzle question. When the 5 pieces are fit together correctly, the result is a rectangle with a calculation written on it. What is the answer to the calculation? Now, when you look at these 5 pieces, you notice there is an operation. The operation is minus, right? It's a minus. So it means something minus something. If you try to arrange them around, you'll find that this one will go to here, right? So that's the best way to fit it. And then you'll find that this one will go there, right? And then you could code this to here and this to there. Okay, so then what you have, right? So what you have is 2 minus 102. If you get all those pieces together, that's how you fit them. Okay, so it's a negative 100. Problem number 5. Here we have a define operation. We define this. Right, so this is just how we define it. Okay, so A this B equals A times B and plus B. Right. So here again, when the multiplication is involved, when letters are involved in the multiplication, we often omit the multiplication sign. So this one means A times B. Okay. All right. Okay, so now here says if we have number X, so X do with 1, 2, with 2 first, and then this resulting number do with 3, and you get 69. All right, so how we do it? So first of all, let's say this one is question mark. So first we have question mark with 3 equals 69, right? Okay, well, we just apply this given rule. So have this mark question mark times 3 and plus 3 equals 69. And from here, I mean, just quickly get this question mark equals to 66 and divide by 3. So we get is 22, right? So we get this one is 22. Okay, so I get X with this equals 22. Now, right? So we say, okay, what's this?
This again is just 2 times x plus 2 equals 22. So from here, I get 2x equals 20. So I get x equals 10, right? Okay. Question number 6. This again is the puzzle. Here, what we have is the multiplication of two 3-digit numbers. And the multiplication is calculated using the vertical method. When you observe those things, you can quickly get, you say, okay, so this one has to be, all right, this one has to be 5, right? No, this 5. This one has to be 5 because 5 goes down to 5. And then this one has to be 0, right? Okay. And then because it shifts to here, this one is 1, so this one's 1, it has to be 1. If this one is 1, you get what? You get this one has to be 1 and this one has to be 1. You cannot get anything else, right? Okay, and besides, because it shift to this position, so I get this one has to be 0, right? Okay, so that's how those are the numbers I can get very quickly. The others are not so obvious at this point, but let's see. Okay. In order to get a 5, I know I can get, and also you do multiplication, you get a 4-digit number. So this one has to be either 3 or it cannot be 3 because 3 cannot get a 4-digit number. So you say, okay, you can either, this is 5, and a 5 is also, if you multiply that, you are not able to get a 5. Okay, so 5 is impossible. So the only way you can have is either 7 or 9, right? You say, okay, so this one is either 7 or 9. That is the possible that you can get a 4-digit number, right? You can get a 4-digit number. Others are all impossible. Okay, 7 or 9. But if it's 7, you see, let's see. What about 7, right? What about 7? So if 1, like this is 5, you multiply by 7, you have to get something which is 5, but it has 0, right? So can we do that? Well, you see, 7 times 5 is 35, so the 3 here. In order to get a 0, right? Then the only thing you can put is it's 1 here. So 1 times 7, you get 0. But then you are not able to get a 4-digit number. So 7 is also impossible. Okay, so we just remove this, right? It's remove this. Okay, so then this tells us by eliminating the other options like 1, 3, 5, 7, we know, okay, so the only possible way, this one is 9, right? If this is 9, then in order to get 0, so 9 times 5 is 45, you get there, we have 6. All right, so then the only way is this is 4, right? So that's the 4, that you can get 0. Okay, so 0, and then you say, okay, so this will be 45, right? So, okay, and then 145 times 9, right? 5 to the 4, 36, 0 to the 4, 1, 3. Okay, so this is 1, 3, 0, 5. All right, so then everything will be, if you just add together, will be 5 and 8. All right, so this is the two missing numbers in the multiplication. So 5 plus 8, which is 13, right? Which is 13. Question number 7. A, B, C are 3 distinctive positive integers that ask the collection of all the 3-digit numbers formed by ABC. That means we just do the permutation like ABC, BAC, CAB, right? In total, we have 6, right? Okay, so if the difference between the largest and the smallest number, it also, if you take the difference, also is number in S, right? Which means, again, it's a permutation of ABC. What is the largest number in S? All right. Okay, so without loss of generality, we can assume that A is bigger than B and bigger than C. Okay, let's assume this, right? It doesn't really matter. I mean, okay, so then this is bigger than 0, right? Okay, bigger than 0 because it's positive. Let's say it's this is bigger than 1, right? A is less than 9. Okay, all right. And then it says then the largest. What is the largest? The largest number is A, B, C. And what is the smallest? Smallest will be C, B, A. You take the difference, okay? If you take the difference, is still, okay, so you get a 3-digit number, is still, so the problem basically says this is still a permutation, right? It's a permutation of A, B, C, right? Okay, so that's the problem says. If you take those different still permutations, still a permutation. By this, you know, because C is less than A, and if you take the difference of B has to lend a number to C, so we get this one has to be 9, right? So this one has to be 9. Okay, so if this one has to be 9, it tells us the A. So from here we say, okay, we get A has to be 9, right? So okay, so we get this one has to be 9. This one has to be 9, right? Okay, so if that's the case, now we know this one has to be equals to B, right? It cannot be C, because C minus 9, if you look at the last digit, you cannot get a C, right? You cannot get a C. Okay, all right. And then we just get this one will be what? This one will be B, right? So this one will be B, and this one will be C, right? So this one will be C. Okay, now because here again I have to borrow 1 to B. So from here I get 8 minus C equals C. So I get C is 4, right? If C is 4, then I get a B is 5, right? B is 5. Okay, let's double check. So basically we just get is 954 minus 459. Let's see what do we get, right? So this will be 5, this will be 9, and this 4. You say, okay, again, it's a permutation of these 3 numbers, right? All right, so then we get the largest one. What's the largest one? So the largest one is 954. Question number 8. N students attend a math computation. So it's okay, we have N students attend a math computation. Each one's score is different. Positive integer. If the total score is 200, what is the largest possible number of N? You see, if I try to get as many as possible, what we have is basically you say, okay, well, because they're different numbers, right? So different part integers. Okay, at least you can have it's 1 plus 2. It's the smallest is 1. So second is 2, 3, and right? You say, okay, you want to add together, this is like 200. But not exactly like this, but we try to estimate, okay? So if you try to estimate, you'll find if I 1 plus 3, plus 20, let's say, right? What do we get? We just want the, right? You just calculate those numbers in your head, and you see what we get. This is 220, right? Okay, this is bigger than 200, so that means 20 people is too many, right? It's not going to work. If you have 20 people, the total score will be at least 210. So, which is greater than 200. So that means okay, let's go down a little bit, right? So okay, how about 19? So if it's 19 people, so if it's 19, so then I'll get 1 plus 19 times 19 and divide by 2, so it's 100. All right, so this will be less than 200. Okay, so which is okay. So which means if I have 19 people will be okay. For example, I can just have the first one is 1, 2. So for example, I can arrange them to make it work, right? So you can like 1, 3, and that one is 18. Then the last one, let's say we can just put it's 19 and plus, because from 190 to 200, it's 10 more. So I just need to add 10 more, right? So let's say the last one will be 29. So it's 1, 2, 3, 4, all the way to 18. And the last guy say its score is 29. And the total one is 200. And it fulfills our requirement that each score is different positive integer. Of course, this is not the only way to arrange it. You can try, there's many other ways. But the point is 19 is the largest possible number of students. Okay. Question number 9. This again is problem with algebra puzzles. In the list P, Q, R, S, T, U, V, each letter represent a positive integer, and the sum of the values of each group of 3 consecutive letters is 35. Okay, so let's put the P, plus Q plus R, right? Okay, plus S plus T plus U and plus V, right? Okay. Now, let's see. We know these three added together is the same as these three added together, right? So they're all equals to 35. What does this tell us? This tells us that P and S are the same. So this is the same as P because both of them add Q plus R is 35, right? Okay. And similarly, you get, you just got by the same thing. You get this one is also equals to P equals to S, right? If you consider these three number, then these three number, right? All right, and then similarly, you get this number Q will be the same as the T. So T will be equals to Q, right? And then you have, we'll have, let's see, let's use the color. So then we'll have this R will equals to this R, right? So this U and R, they'll be the same. Okay, let me rewrite everything. So we have this P plus Q plus R plus S plus T plus U plus V. So what do we have? We have the P and S, they are all the same. So this is also P, and this is also P. It's the same as P and S, right? So this is what I have. Okay, and then we'll have, this is R. This R and U, they are the same, right? Okay, so let's say this is the same as U, right? Okay, and then we have this is the Q, right? So this is the Q. So this is the Q, and the T, this is also Q. They're the same. All right, so then the total sum, what do we get? We get the total sum is equals to 3 copies of P plus 2 copies of Q and plus 2 copies of U, right? So that's what we have. Okay, so then we just have, right? Okay, so we say, what do we get? We'll just have, this is the P, right? So P, and also you see PQR, let me put it here. These three, they add together is equals to 35, right? So, okay, so we have P plus Q plus R, so it's, which is 35, but R is the same as U, right? So it's P plus Q plus U, this is 35, right? Okay, so what do we have? So from here, we'll just Q plus U equals 15. So that's what I have, right? We just catch those numbers. So I get a P is equals 20. So P is 20. All right. Okay. So then this one will be 60 because it's P times 20, and then plus twice because Q plus U is 15. It's given by the problem, right? It's mentioned. So this will be times 15, right? 2 times 15, 2 times 15. So if you add them together, so it's 60 plus 30, which is 90. Problem number 10, 2 groups of students attend a math computation. Okay, so here we have, this is group 1, right? So let's say this is group 1, and here we have, this is group 2, right? Group 2. Now group 1 has, right, group 1 has 16 students. Group 2 has 24 students. Okay, so here we have the average score of group 1 is 83. In group 2 is 78, right? 78. Okay, so that's what we get. The question is, if you combine all those things together, what is the average score? Okay. All right. First, let's compute the total score. Right? Because the average score is the total score, right? It's the total score, and divided by the number of students, which is 16 plus 24, which is 40, right? So all we need to figure out is what's the total score. So score is, we look at from group 1, the total score in group 1 is 16 times its average, 83, and plus 24 times its average, which is 78, right? Now, when you calculate those things together, and you can do by yourself, which you can get is 3 1,200. So you get the average score will be 300 to 1,000 divided by 40. So that's what you get is 80. Okay, problem number 11. In the following figure, a bog cross along the arrow. The length of each edge is 3, right? So there's 3, okay? It starts from D. Okay, so it starts from D and it moves toward A. So this is one edge, right? And then from A to B, and then from B to C, and then from C to D. Okay, because it cannot turn around, right? So that's when it does not make any turn. So that means it has to move forward like this, move here and then, and then, and then. But when it get back to C, again, it cannot turn around, so it has to move. Just basically repeat the cycle. Okay, so here we get it's each cycle, right? Has the length is 3 times 4 times 2, which is 24, right? So that's each cycle, the length, right? So length of each cycle is 24. Here it says the clock 224, right? 2024. Okay, let's do it. So 2024, let's divide by 24, right? We try to find the remainder, right? Okay, let's see how should we have here. This what we have to be 8, right? 2, this is 119, right? 19. Okay, this will be 0, this will be 1, and this will be 4. So what should be here put here? We should be put 4. This will be 9, 6, right? Okay, what's the remainder? The remainder will be 8. Okay, so that means after 84 cycles. So this is after 84 cycle, and the remainder is 8. Now, if it's 8, what shall we get? So this will be 3 and 3, and then you have extra 2, right? So 8 is 3 plus 3, right? 3 plus 3 and plus the extra 2. So after this, the end will be right here, right? So the end is here. Okay, so that means it's if you look at all the vertices, it's close to this guy. So C. So the answer is C. Problem number 12. There are 3 numbers A, B, C, right? And A equals 3/4 of B, right? And B equals 5/6 of C. The question A is equals M times N of C, right? This is a simple question. You can just replace B by here. So this will be 3/4 times 5 of 6 times C. And here you see if I do cancellation, so I get, okay, just 5/8 C. Okay, so I get this one just 5/8. So M plus N equals 13. Question number 13. 3 cups of the same size are filled with alcoholic drink. The ratio, okay, so here we have 3 cups of alcoholic drink of the same size. The ratio between the volume of alcohol and water in each cup is 1:4. So this is 1:4. Okay, so here is it's alcohol to water, pure water. Okay, 1:4, 1:5, and 2:7. Okay, so now combine this, mix this into 1 cup. And then we have the ratio between alcohol and water is M to N. And the question is, okay, what is M minus N? Here, of course, we require that M and N to be relative prime, which means the only common factor they have is 1. All right. Okay. From here, let's first find the alcohol, the ratio of alcohol of the whole. So to the total. So total means water plus alcohol. Okay. This one will be 1/5, right? So this will be 1/6, and this will be 2/9. Now we mix them together, right? So we mix together and divide by 3. Okay, so this will be the ratio, right? So this ratio, when you mix those in together, because you can assume the total will be 1, 1, 1, right? Okay. Now this will be the ratio if you mix. Okay, so this is you mix. This is alcohol, right? Alcohol to the total, right? To the total. Okay. Let's find out. Okay. We can find the common denominator to compute this addition of fractions. Obviously, the common multiple of 5, 6, 9 is 90, right? So the LCM, so we find LCM of 5, 6, and 9. This is 90, right? So you add them together, will be, so you add these three things together, right? Okay, so it's 18, which is 105, and then plus this 15, and then plus 20, and divide by 3. Okay, let's see what we get. So this one we add together will be 53. Okay, so we get is 53 over 270, right? 270. Okay, so this is in the mixture. In the mixture, the ratio between alcohol to the total. So total again, so it's water plus alcohol. All right, 53 and 270, they're already applying. There's no more, we can reduce them. All right, so then from here, I can deduce the ratio between alcohol, right? So ratio between alcohol and water will be 53 to the 270 minus 53. So what we get is 53. This will be 2, this will be 1 and 7, right? Okay. All right. So then we get this will be the ratio we are looking for is mn, right? So this will be n and this will be n. Okay. So that's what we have. So we have m equals 53 and n equals 217. Now what we are looking for? We are looking for is m minus n, right? So m minus n will be 217 minus 53. So what we get is 164. Question number 14. They are the same number of boys. Okay, so we have same number of boys and girls on the playground. Later, 10 more boys and 5 more girls to the playground. Then the ratio, okay, so after this, you add these new numbers, right? So then the ratio between them becomes 7 to 6. The question is how many boys are in the playground at the beginning. All right, so let's use algebra. So let's say the total number is x, and this will be x, and then we just quickly get our equation. So that's x plus 10 over x plus 5, which is 7 over 6, right? Now you see, if you have two fractions that are the same, just means the cross product will be the same. So from here, I get a 6 times x plus 10 will be 7 times x plus 5, right? So this is just equivalent way to say the two fractions are the same. Okay, so from here, we just get a 6x plus 60 equals 7x plus 35. Okay, so we just get x equals, right? You just solve the equation, you just minus 6x, right? And then you move 35, then you minus 35, minus 35. And then you just get, so this you get is 1x, okay, you get x is 60 minus 35, and then we get is, the answer is 25. Question 15. 24 people are working on a project that's scheduled to be done in 12 days. Okay, so we have 24 people on a project that's done in 12 days. Now, after these 24 people have worked for 4 days, okay, so they finish for 4 days amount of work. So 4 days, right? So total is 12 days amount of work or project, whatever you put it. All right, okay, so here is you use the 24 people work on it. And then for this part, you said, okay, after 4 days, like 8 more people added, right? Join the project. So this is, here is 24, right? 24 people. And then what we get is 24 plus 8, which is 32 people. Okay, now if it's 32 people, then of course you have more. Then here we just need how many days we need for this part? So we need is 24 over 32. Because you have more people, of course, it requires less amount of time, right? Okay, so then we know that 24 days, this left is 8 days, right? 8 days. But if you have 32, so it's the fraction will be multiplied by 8, right? So this is you need how many days if you have 32 people. Okay, so let's calculate this. You just get 6 days to finish it, right? So 6 days. So here you see, okay, you actually just need 6 days to finish this part, right? So then the answer will be 6. Okay, question number 16. One morning, Austin's dad drove him to Calvary Church. Okay, so drove him to Calvary Church. This is home, and here is the church, where Austin would board a bus for some retreat. They planned to leave home at 7 a.m. and drove at 30 miles per hour to get there on time. Okay, right on time. But however, due to an unexpected delay, they actually left home at 7:10, right? So of course, then you have least amount of time to reach the church, right? To get on that on time. That means you have to drive faster, right? Okay, so it says 70 miles per hour. It'll get there. And the question is, okay, how far is the church from Austin home in miles? You can again, let's use just algebra. Let's say it's L miles, right? It's L miles, and here is the distance, or let's say as x. Okay, that's the usual variable. Let's say it's x miles. Then we know the time. Okay, so in order to get there, I say okay, we just need the time. If from here to here, we have is the distance divided by your speed. So that's time you get there on time, right? But if you go with 40 miles per hour, you can save for 10 minutes, right? Because it's left 10 minutes later. And with this speed, again, it arrives at the same time, right? Arrive at the same time. So that means it save 10 minutes. All right, so what we have is this one plus, we get the equation is this one plus 10 minutes. You transfer to convert this to hour. So it's 1 of 6 hours equals x over 30. So this is the equation we have, right? So this is the equation we have. And then you can solve this. Let's multiply, okay, so we have 1 over 6 is x over 30, right? 30 minus that x over 40. Okay, so we can use the common multiple, which is 120. So this will be 120. Okay, so 120 to the x. Okay, so from here you just get x is 120 times 1 of 6. Then you get this is 20, right? So it's 20 miles. There are 20 miles between home and. All right. Okay, question number 17. There are 4 people. Some of whom always tell the truth. The others always lie. The first person said an odd number of us always tell the truth. The second person said an even number of us always tell the truth. The third number said a prime number of us always tell the truth. Okay, well, if it's there 4 people, the prime number means 2 or 3, right? The fourth number says a square number of us always tell the truth. Well, again, because it's from 1 to 4, the square number will be either 1 or 4. So 1 or 4 are the only 2 square numbers from 1 to 4. Okay, the question is, all right, based on those statements, how many of them are actually telling the truth? All right, so what should do? Hey, because there are only 4 people, so let's just do case, right? We try to eliminate those which are not correct. Okay, let's do it. All right, so case 1. Let's say, how about let's say n is the n is the number of people, right? So number of people who telling the truth. The truth. All right. Case 1. Let's see. Is it possible that n is 1? Right. Okay. Let's do 1 by 1. Is it possible? Well, if n is 1, that means this will be correct. The statement of first person that an odd number of us always tell the truth. Okay. This is always. Okay, so that means statement 1 is correct. The first person is telling the truth. The second person said an even number. Okay, so this guy is false. The third person said a prime number of us always tell the truth, which is false, because one is not prime number. The first person said a square number of us always tell you, okay, one is correct. So that means actually you have two people, they are telling the truth, which contradicts the fact that there's only one person who's telling the truth. So this is impossible. All right, let's look at case 2. What about there are two people who are telling the truth? Let's see whether we can get any contradiction. If it's 2, then the first one is not correct. The second one is correct. The third one is correct because 2 is a prime number, right? Keep that in mind. The first one is not correct. And then you see, hey, yes, they're exactly that 2 person who are telling the truth, right? Who are telling the truth. So this actually is okay. Yeah. If there are 2 people who are telling the truth, then there's nothing wrong with that. And then maybe how about other cases, like case 3? Is it possible that actually 3 people who are telling the truth? Let's see, if 3 people, then we have this one's correct, right? This one's wrong. And this is also correct with a prime number, but this is not correct. Oh, but then in this case, you see there are 2 people who are telling the truth, which is not 3. So, okay, so wrong. And case 4, right? If you case 4, let's see what do we have. If the 4 people who are telling the truth, this is obviously is not correct because this one will just be wrong, right? Because this guy is not telling the truth, so which is impossible. Okay, all right. So finally, we find the only valid case is there are 2 people who are telling the truth. Question number 18. A shop has sold 50 T-shirts of the same original price to 35 customers, right? The policy says buy 1, get 1 for 40, the second one, right? So the second one get 40% off. 20 customers buy 1 T-shirt and 15 customers buy 2 T-shirts. On the average, right, if you combine all those things together, right, discount or without discount, it turns out that each T-shirt is sold at N% off. Question is what N? All right. Okay. So here we have. Let's see the sold price. Okay. For convenience, we can think of the original price. We think this just be 1. It doesn't matter because 1 could represent. Here we do not specify any unit, right? Could it be $1, like 1 of $100, right? It doesn't matter. Okay. So let's just say 1. And then here we have the price, the original price of 50 T-shirt will just be 50, okay, which will be 50. And then sold price of the 50 T-shirt will be what? Well, yeah, for 35, 20 of them is the original price, so it's 20. And the left 15, so 20 get 1 and 15 get 2, right? And 15 buy 2. So 15 is the first one is the original price, but the second one you get is 40% off, so that will be 60%, right? So this is the first one, and this is the second one. All right, so this is what we have. Okay, let's see what we get. So this will be 35, or 20 minus 35, and plus 35 times 60%, right? So 50 times to the 3, right? Okay, so cancel, so you get this one equals 9. All right, so you get is 44. Right, so the sold price is 44, okay? And then the discount will be so the percent will be 44 over 50, which is 88%, right? Sold well at the 88% of the original price, and then discount off will be 1 minus 88%, so it's 12%. All right, so problem number 19, cup A, here we have, let's see what we have. Cup A, this is cup A, has 10 grams. So here's 10 grams, it's 12% of saline. And carbon B, right? Here is selene. So which is the mixture of salt? Selene is salt plus pure water. It's a mixture. And carbon B, let's see what we have. Carbon B is just water, right? It's 10 grams. It's just water. Now, Jack first add 10 grams of 10 grams. So first add 10 grams of 24% selene to cup A, right? To cup A. So first you have like 10 grams, but add another 10 grams, okay, whatever, and mix it well. All right, so then you basically just get a new selene. And let's see what we have. So this new one, so this new selene, what do we have? Its total is 20 grams, right? Its total is 20 grams. And what is the salt, the amount of salt? So salt is how much? Okay, so here, or it will be originally 10 times 12%, and then plus the added one, so 10 times 24%, right? Okay, so that's what I have. And let's see what we get. This will be 3.6, right? 6.6 grams. So this is what in the new gram. The total is 20 and 3.6 grams, right? Well, what's the percent? Will be 3.6 over 20, which is 18%. Right? It's 18%. Okay. Now from this 18%, and then you move out 10 grams, right, and add it to here. Right? Okay, so then you get again, so you get the new selene here. A total will be 20 grams. And the salt, because B is pure water, there's nothing it can contribute in terms of salt. So salt is all from here. So it's 10 times 18%, which is 1.8, right? Which is 1.8. Okay, so then you get the percent of this new one will be 1.8 over 20, which is 9%. Again, it's 9%. So the percent of the new selene is 9%. Question number 20. Give two positive integers in each operation. We replace the larger one by their difference. The operation will stop the two numbers become the same. So here's what happens, right? 20 and 15. We know the difference 20 minus 15 is 5. So you replace this guy by 5. And here, the difference again 5, you replace by this, so until you get a 5. Okay, so basically what I have is, suppose A is bigger than B. The first operation AB will just go to, you replace A by the difference A minus B. So A minus B, and then go to B, and there's such and such. And this is actually the called, this actually is called the Euclidean algorithm to find the GCD. Okay, basically the reason is you can see what the GCD of AB is the same as the GCD of A minus B and 2B. This you can you say, okay, why? You say, oh, why is that? That's because suppose that A is divisible by n. A and B are divisible by A and B, they're both divisible by n, then you get A minus B is also divisible by n. And vice versa. If you know A minus B and AB is divisible by n, you can go back, right? Just add them together. You can say, okay, then A will also divisible by, if you add them together, if A minus B is divisible by n, B is divisible by n, they add them together is also divisible by n, which is A. All right, so you can go two ways. So my point is, it does not change. Right? A number is divisible by both A and B if and only if it's divisible by B and their difference. And this basically tells us the GCD of AB is the same as GCD of A minus B and B. And this, as I said, this is called Euclidean algorithm to find the GCD. If you keep doing this operation, you're able to reduce the two numbers. Like here, you're eventually you're able to reduce 20 and 15 to 5 and 5. The advantage of this is you don't have to do the factorization, right? You don't have to find the factors like in the ladder method. And this is this is the algorithm used by the computer to find the one, at least one of the algorithms used by computer to find the GDC. Okay, so the point is eventually this is 5 equals the GCD of 5 equals the GCD of 20 and 15. So the last, you start from two numbers, the last one you end up with, eventually just end up with the GCD of these two numbers, the GCD of AB. All right. Now, then you have here, you have AB, right? You say, okay, I start doing this operation, eventually I end with 15 and 15. Okay, according to I said, you basically have 15 is the GCD of AB, right? If you GCD of AB. Now, here what we are looking for. We are looking for is what is the largest possible sum of two numbers, and they are such that the GCD is 15. Okay, so we want to find AB is the two largest, right? Two largest multiple of 15 3-digit numbers, right? 3-digit numbers. All right, so then we can easily find this, because if I do 999, right, divided by 15, what do we get? 6, 69, 69, 6, 90, and 9. Okay, so the larger one, A, will just be 15 times 66, and B, just the one right before it. Okay, so times 65, right? 65. And that's what I have. You can obviously see that GCD of AB will just be 15. Eventually, just go to 15. All right, so what do we have? So I have A plus B will just be 15. Right, so are we looking for the, yeah, so what's the sum, right? It's 15 times 16, 6 plus 55, right? 65, so it's 15 times 131, right? So 131 times 15. So what do we have? So there's 5, this 5 and 6, 5, 131. So it's 1965, right? 1965. Yeah, okay. So that's 1965. All right. Therefore, you see, what's the whole point? The key point, yeah, in the problem. The key point is eventually end up. Okay, so eventually stop when the same. So what is the same? The same equals the GCD of AB. That is the whole point, and which, as I said, is called Euclidean algorithm to find GCD.